Hello, good evening, dear students, and welcome to the second video in the previous year question papers. So, in the earlier video, we have solved question number 1, which was from the topic percentage, profit and loss. Now, today we are going to move on to question number 2. So, you can see that there are 4 questions, 2A, B, C, and D, of which we need to attempt either A and B or C and D. These questions are from the topic interest and annuities. So let us start solving this. Here I have cut pasted the questions. We'll begin with question number 2A. Let us read the question first. What should be the rate of simple interest so that a sum invested today will double itself in 15 years? Now, if you will see in the question, we don't have a lot of detail. This problem is known as the doubling the principal problem. We need to find out the rate of interest in which the sum invested is going to double after 15 years. So, for example, if I have invested rupees, say 1000, then after 15 years, the amount should be 2000. Now, in this question, the principal is not given to us, so we will take an easy to do with number. To begin with the solution, we want to know what is the rate of interest. So let me say R is equal to question mark. A sum invested today. So the principal is also not given. Let us assume that the principal is 1000 rupees. You can take any other number, but try to keep the number as simple as possible. The investment needs to double. That means the amount is going to be 2000 rupees. Since our principal is 1000, the amount needs to be 2000 and it should be happening in 15 years. So N is 15 years. We know that the amount can be evaluated as the principal plus interest. So if we plug in the values, we have 2000 is equal to 1000 plus I. And on simplification, we get I is equal to 1000 rupees. That means that the interest needs to be 1000 rupees in 15 years. We also know that in simple interest, the formula for interest is PNR upon 100. Let us substitute all the known values. I is 1000, P is 1000, multiplied by N, that is 15, multiplied by R, which we need to compute, divided by 100. And on simplification, this is going to give us that R is equal to 100 upon 15. And on the calculation, we get R is equal to 6.67%. So thus we can write on the final answer. The required rate of simple interest must be 6.67%. Let's come to question number 2B. This question is from the topic annuity. Here we have been said that find the amount of ordinary annuity if the payment of rupees 500 is made at the end of every quarter for 1 year at the rate of 16% per year compounded annually. So if you will see here, this is R, the periodic payment. Now the payment is made every quarter. That means the multiplier factor will be K equal to 4. Since for every year there are 4 quarters, so the payment needs to be done next, and the interest also needs to be distributed by 4. The period of the annuity is 1. We use small n, so n is equal to 1, and the rate of interest is 16%. That means R is equal to 16. Now coming to the formula of annuity, the formula of ordinary annuity is A is equal to R 1 plus I raised to n minus 1 upon I. Now, since we have here to deal with every quarter, so we need to add this multiplier in the formula. So we are going to modify the formula and we will say that A is equal to R 1 plus I divided by 4 raised to 4n minus 1 divided by I divided by, and we are given in the question R is 500 rupees followed by 1 year, that is n is equal to 1. The rate of interest is 16, so R is equal to 16 and I is R divided by 100, so that becomes 0.16. Let us substitute all these values to find out the amount of the annuity. We will get 500 multiplied by 1 plus I, that is 0.16 divided by 4 raised to 4n, that is 4 multiplied by 1 minus 1, and entire thing divided by I by 4, which is 0.16 divided by 4. Now on your calculators, you need to do a series of calculation. We will keep in touch with the basic BODMAS. So we have a bracket over here, 1 plus 0.16 by 4, and here we have an addition and a division. So we'll perform division first. So on your calcs, you will hit 0.16 divided by 4 plus 1. Now we need to do the order. So we have the power as 4. So this is going to be raised to 4. So on the financial calculator, we do not have a key to evaluate the power. So we are going to hit multiplication and equal to 3 times. Since it is power 4, so we need to hit the equal to 3 times. Had it been let's say power is 8, then we will hit equal to 7 times. And then we need to do a minus 1 divided by 0.16 divided by 4, and then lastly we need to multiply everything by 500. Once you do this, you get the value of A as 2123.23. So that is the amount of the ordinary annuity that we'll be receiving after contributing 500 rupees 4 times in a year at the rate of 16% per year. And hence our final answer is the amount of ordinary annuity is 2123.23 rupees. Let's move on to question C. Here we have a sum borrowed at 24% interest is to be compounded monthly. It was repaid in 12 equal installments of 1300 rupees each, paid at the end of each month. Find the sum borrowed. If you will see that it is an EMI problem, and this topic comes up from the same section of ordinary annuities. The EMI is given to us in the problem. We wish to find out what was the sum borrowed, so that the EMI comes up as 1300 rupees per month, and that needs to be paid for 12 equal installments. The rate of interest given to us is 24. The EMI value is 1300. And since it is only 12 equal installments, means the period for which the money has been borrowed is 1 year. Let us write down the data first. We have R is equal to 24. That will give us I is equal to 24 upon 100, which is equal to 0.24. Then we have N equal to 1, and the EMI value or the periodic payment. So R equal to EMI is equal to 1300 rupees. To find the sum borrowed, we will use the formula of EMI. We have P is equal to R into 1 minus 1 upon 1 plus I raised to N divided by I. Now, since the installments are monthly, so we will attach a factor of K equal to 12 in the formula. That will be fitting over here as well as here. So I'll make the changes here itself. So instead of N, we will have 12N, and instead of I at both the places, we will have I by 12. Now let us substitute the values. R given to us is 1300. Then we have 1 minus 1 upon 1 plus I by 12. I is 0.24 and 0.24 upon 12 is going to be 0.02. This needs to be raised to 12n. N is equal to 1. The entire expression divided by I by 12. Again, I by 12 is 0.0. This complex calculation can be performed in one go on your calculators. For that, you need to do the following series of keys. So we will begin with the denominator. The denominator is 1 plus 0.02, hit equal to. After hitting equal to, we need to find out 1 upon 1.02. So for that, simply we are going to do divide and equal to, and that is going to give us the reciprocal. Then we need to find out 12 raised to 12. So we are going to press multiplication and hit equal to 11 times. And then we will do minus 1. Now note, when you do a minus 1, you will be getting your answer in negative. That minus sign can be taken care towards the end. Then entire this expression needs to be divided by 0.02. And finally, we will multiply it by 1300 and press equal to. Once you do up this series of keys, you are going to end up getting the value of P as 13,747.94. So this is the sum which has been borrowed. And that's our final answer. Now moving on to the last question of this video, that is 2D. We have, when all the banks are giving interest at 8.75% compounded quarterly. So we have a rate of interest which is 8.75 and that is compounded quarterly. A bank comes up with a scheme of simple interest at the rate of 10% per annum. Calculate which scheme is better for the customer for the investment for 4 years. So if I am a customer, I come across two situations wherein one bank is offering me a rate of interest which is 8.75 PCPA, and this is compounded. So the rate of interest is compound interest, and this is compounded to me quarterly. There's another bank which is offering me a rate of interest as 10% per annum, and this is simple interest. We make investment in both the cases for 4 years, and we are trying to find out which of the two is going to be a better one for the customer. So let me again take the principal as a simple number, say 1000 rupees. We are going to evaluate the interest or the amount in both the cases. and wherever it is going to be more, that is going to be beneficial to the customer, and hence we are going to select that scheme. So for compound interest, we have the formula for amount as A is equal to P 1 plus R by 100 raised to N. Now since this is compounded quarterly, we need to attach a factor of 4 with N, and we need to divide the rate of interest by 4. Substituting the known values, P we have assumed it to be 1000 rupees. 1 plus R, that is 8.75. 4 times 100 becomes 400. 4 times N is equal to 4. This is going to be 60. On your calculators, we will again start with the BODMAS. So first we are going to go for 8.75 divided by 400 plus 1. After that, we need to raise the power to 16. So into, and then press equal to 15 times multiplied by 1000. This series of calculations on the calculator leads us to the value of A as 1413.7. So of which 1000 is the principal, so the interest which we are getting is 413.72 rupees. Now coming to the other scheme, the new scheme. So since it is simple interest, we have the formula for interest as PNR upon 100. P is 1000 multiplied by N, which is 4. The rate of interest is 10 divided by 100. And this gives us the interest as 400 rupees. Lastly, we need to compare both the interests. So in the existing scheme, wherein 8.75% compounded quarterly is done, the interest earned after 4 years is 413.72, while that in the new scheme which a bank has come up at simple interest of 10% per annum, the rate of the interest accumulated is only 400 rupees. So from customer's perspective, we can say that scheme 1 is better. So that concludes with today's video. Wishing you all the very best for your examinations. If you have any query or doubts, you can come up in the comment section. And thank you for watching till here.